Hello, and welcome to EELE 261 Introduction to Logic Circuits. My name is Brock Lemires, and I will be your instructor for this fully online summer course. The purpose of this video is to get you started with the course. So what I'd like to do is first talk about the motivation for the course and what type of material we're going to cover. Next, I'd like to introduce myself because I'm the voice and the hands that you'll see in the video, so it'd be nice to know who is actually talking to you. And third, what I'd like to do is go over the course logistics. So we'll go over the schedule and the grading and the flow and talk about the deadlines and the actual structure of the course. And then we'll look at some of the programmatic stuff in Brightspace Learning Management System, which is where you're going to actually complete a lot of the activities and access course materials. Before we begin though, it is very important that if you're watching this, you have your lab kit. All of the laboratory exercises in this course are going to be conducted using a portable lab kit. So if you are watching this video, you should have either checked out your lab kit or provided an address to me so that I can ship you your lab kit, because you will need this on day one of the course. So please make sure to contact me immediately if you do not have this. So let's get started.
This course is about the basic building blocks of a modern computer. So when you think about what a computer is, it is a collection of hardware and software that work together to perform a task. And you've probably dealt with software before where you write programs in C or Python and say hello world, but those programs are run on computer hardware that actually execute the instructions to accomplish that task. What we're concerned with in this class is about what is the underlying hardware, what are the circuits that exist in that computer that can actually interpret the software and perform the task. And the circuitry that exists is called digital. And what digital means in its simplest sense is that it just operates on ones and zeros. Okay, so the circuits that are built there are going to take ones and zeros as their inputs and produce ones and zeros as their outputs. But most importantly about this class, we are focused on the hardware aspect of a computer, not the software. And what we want to do is we want to build up this basic understanding of what is going on underneath the computer so that someday we can actually create a full-blown microprocessor and add memory to it to actually implement a full computer that could execute software. So how do we get started learning about the underlying hardware? Well, we break this course into 7 modules, and by no means is this a comprehensive coverage of a full computer system. It takes numerous courses and a great deal of time to understand the exact details of a computer, but this is just a start to get a basic understanding. So what we do in this class is we start with understanding what is a digital signal, and we do that by comparing it to an analog signal, and that just gives us a basic understanding of how you represent these ones and zeros that we hear about in a computer with electrical signals such as current and voltage. Then, since we're going to be operating on the binary number system, we always hear about ones and zeros. Well, you can think of it as the circuits that sit within a computer. They interpret information using the binary system. And so if we're going to build circuits to do that, we need to understand the binary system. And so what we do is we typically look at the decimal number system that we use as humans, and then we look at the binary number systems, and we look at conversions back and forth between them. And then we also look at how you do operations in binary. So things like addition and subtraction, and think about some of the nuances of doing that and how that impacts the types of circuits that we need to build. Then what we do is we actually look at common digital circuits. So we look at the basic gates that perform operations on ones and zeros. And these are very simple. These are things like an inverter that if the input is a 1, the output will be a 0, and vice versa. And we start at a very low level, and we actually look at the electrical interfacing of these circuits so that we can actually build larger circuits. So we not only just want to understand how they work, we want to put them together and actually send ones and zeros back and forth using electrical quantities and have the circuits operate as intended. So we look at power supplies and grounding and logic levels and get to the point where we kind of understand how you build these circuits. Then what we do is we move into actually designing combinational logic circuits. And a combinational logic circuit is the first kind of digital logic system that we learn how to design. And there's techniques to synthesize circuits. So we'll look at how you take a description of a logic circuit and actually come up with the gate level or the circuit level implementation of that. And then we'll get hands-on experience with actually building the circuits and testing them. And then what happens is you immediately run into this situation where the circuits that you build become very large very quickly. And the pen and paper approach that we learn in Module 4 becomes impractical for large circuits. So we have to change the design methodology that we use in digital systems to one that is more hardware description language based. So you can kind of think of this as you're going to type out the description of the circuit that you want, and then we'll allow a computer tool to actually synthesize the circuit for us, and then we can take that circuit and build it in hardware. And this is how modern digital systems are designed. It is a language. It's not necessarily called a programming language. It's a hardware description language because you really are just trying to describe the circuits. And the language we're going to use is called VHDL, and we'll go into that in great detail. But you're going to get experience actually typing out descriptions of circuits and using a modern tool to actually synthesize the logic. And then what we do is we look at some larger circuits that are very commonplace in computers. We call this MSI logic. It stands for medium scale integrated circuit logic. But we look at things like decoders and encoders and multiplexers, and this just gives us some practice of saying, here's a relatively complex circuit that would be hard to design by hand. And so what we'll do is we'll use this hardware description language and describe its functionality, and then we'll go ahead and simulate it and then synthesize it and build a circuit to implement it. So we'll run through a handful of those circuits just to get practice. And then we'll move into finally the last module, which is called sequential logic. And sequential logic really gives us a view of the more complicated tasks that a digital circuit can perform. And the big thing from sequential logic is this finite state machine. So we're going to be able to build a circuit that can make decisions on how to assert its outputs based upon the current values of inputs in addition to past values of inputs. And this gives us the mechanism to create a system which is somewhat smart about what it's doing. It is able to look into the past and look at what has happened before in order to determine what it should do now. And that starts forming the brains of a central processing unit in a modern computer. So that's the flow that we're going to take in this class, 7 modules that we'll walk through. So how do we learn this material? Well, this class is a fully online course, and so we're going to teach the material just like we do in a traditional live class, except instead of coming to class, you're going to watch videos. And so before we get into kind of the programmatics of the class, since I'm the voice in all the videos and the hands that you're going to see on some of these videos writing on paper, and also the author of the textbook, I thought I'd give you a quick bio on myself just because it's kind of good sometimes to know who is actually talking. So again, my name is Brock Lemire. I am a professor at Montana State University. I've been at MSU for 13 years. I got my bachelor's degree from Montana State University back in the 90s, and then I went to work for Hewlett-Packard in Colorado, where I was a hardware design engineer. And I worked there for 8 years where I designed acquisition systems for test and measurement equipment. So things like logic analyzers and probing systems for oscilloscopes and logic analyzers. And so in that role, what I was able to do is learn about how products use digital circuits to accomplish tasks. And in that role, it was cool because I got to use all the computer engineering material that I learned at MSU and was able to build systems, printed circuit boards and programmable logic, design programmable logic devices and just digital systems and see how everything came together. So after working there 8 years, like all big companies, HP would pay for you to get your master's and PhD and nights and weekends. So I chipped away at that at the University of Colorado. And I got my PhD from CU in 2005, and then a position opened up at Montana State, and so I was able to get that and move back to Montana. And since coming to Montana State, what I've been working on is on the research side of things, I'm trying to look at how do you build optimized digital systems. So, if you think about a digital system, we always think about, well, it's just a computer, a microprocessor, and then we write software to accomplish the task. But today we have capability to actually optimize the hardware in addition to the software, and that's namely through advances in programmable logic devices. And so we're at a point where we can develop systems where not only is the software able to be updated rapidly, but the hardware can be updated rapidly. And this moves us into kind of this notion of reconfigurable computing. So that's been my area of research for the past decade. And what I've done is I've been able to apply that to aerospace applications. So primarily my computer engineering work is funded by NASA. And what I've done is come up with a variety of architectures that we've tested in, exciting environments, such as on balloons or on the space station. And currently I have a small satellite that is orbiting Earth. And so this is a picture of kind of the stuff that we build here at Montana State. This is a small computer that implements some of these novel architectures to be optimized for operating in space. And primarily this is just to avoid radiation-induced faults. And so here's our computer that we built on the International Space Station getting installed. And then, like I said, we have a small satellite that was deployed last summer and is orbiting Earth right now, trying to collect data on how well it behaves in the presence of radiation. So that's kind of my research expertise on the technical side. I also am the director of the Montana Engineering Education Research Center. And in this role, what I'm trying to do is just investigate how to better teach engineering. So, teaching engineering today is a lot different than maybe 30 years ago. 30 years ago, you taught engineering by just writing on a chalkboard. Everybody watched the teacher teach, and then they read, and then they did homework, and you repeated that 3 times a week, and you were done. And that works pretty well, except that now there's such a demand for engineers that we need to find a way to expand or broaden the way that we teach engineering so that more people can succeed in an engineering curriculum and ultimately just expand the engineering workforce, because the problems of tomorrow are very complex and we need a lot more and diverse types of engineers in the workforce in order to solve these problems. So I've written some books, and one of the books we'll be using is this Introduction to Logic Circuits and Logic Design. And I also conduct research on motivation of first year engineering students and looking at how to strengthen the pipeline of K through 12 students coming into engineering and all sorts of stuff like that. So that's me. And like I say, you'll hear this class is essentially going to be watch videos, read the book, and then perform online activities such as multiple choice quizzes, and then build lab circuits using this portable lab kit. So the voice and the hands that you see are all me, and like I say, I wrote this textbook, so everything is kind of coming from me, so that's my background. So let's now look at the programmatics or the logistics of this course and actually see the details of how you're going to do this. So to start off with, I'm going to show you this flyer that is advertising the courses in digital logic for this summer. And it's important to note that this is part one of a two-class sequence that covers all the materials in this book. And what you're in right now is called EELE 261 Introduction to Logic Circuits. And what we do is we cover the first 7 chapters of the textbook. And there's a follow-on class called 367 Logic Design, which covers chapters 8 through 13. And the follow-on class to 261 really covers everything using the hardware description language approach. So you're able to model much larger circuits, and at the end of that is where you really get the full understanding of how to build a computer. In fact, the final project of chapter 13 is to build a full computer and program it in assembly language. But what we're looking at 261, which is Introduction to Logic Circuits. So when we think about what we're going to do in this class, we are basically going to do this low-level understanding, like what is a gate? How do you take an AND gate or an inverter and design a circuit using those parts and put them together and actually build something? And so when we talk about this, I want to make sure that you're aware that there's actually different schedule options for the summer of 2019. So there's a 4-week session that starts in May. There's also a 4-week session that starts in June. There's a 6-week session that starts in May. And then there's a 12-week session that starts in May and ends in August. And all 4 of these are running concurrently, but they're identical in content. They are absolutely identical. All the grading is the same thing. And you use the same lab kits. They're all identical. The only difference is how fast you complete the course. So I want to make that clear, because if you ever get in a situation where you start one of these 4x4s and you realize it's too accelerated, you can switch to the 6-week, or you can move to the other ones, but you have to kind of decide relatively quickly. To complete this course, you're going to need 4 things. Okay, the first thing is going to be a computer. Now, you obviously have a computer if you're watching this video, maybe, right? You could be watching this on your phone, but you are going to need a computer that runs Windows, okay? And the reason you need Windows is because we're going to be using software that only runs on Windows. And I'm sorry, it just doesn't run on a Mac. There's no way around it. The software is used to actually simulate some of these logic circuits. And it is supported on Linux, but it just doesn't work on a Mac. If you have a Mac and you're going to try to make it work, you got to be able to find a Windows machine that you can install this software on. And that comes into play when we get to Module 5. So you have a little bit of time to figure that out. The other piece of software we're going to use is it's a measurement software that runs a portable instrument, and that does run on Mac. But like I say, you need access, or you need to have a Windows machine. So that's the first thing you need. Second thing you need is the textbook. So this is the 2nd edition, Introduction to Logic Circuits and Logic Design. If you have the 1st edition, that's fine too. The only difference between the 1st and the 2nd was fixing typos and mistakes, and then adding a significant number of homework problems. And so if you have the 1st edition, you can absolutely use that. And then the third thing you're going to need is the portable lab kit. Okay, and you're going to get a box, and what's going to be in this box is going to be kind of 3 sets of stuff. So the first thing is going to be an Analog Discovery 2, which is a portable instrument. And this thing is truly amazing. You plug it into your laptop or computer, and you run a piece of software called Waveforms. And this instrument will actually allow you to take oscilloscope measurements, logic analyzer measurements, voltage measurements. It'll also produce waveforms, so you can drive out a square wave or a sine wave. You can actually power your circuits. So this thing is everything that you would have in a laboratory environment on your desk. Okay, and it's just unbelievable. And so what we do is we check this out to you. You got to give all this stuff back. But we're going to check this out to you, and we'll walk you through how you use it. But this is going to be like how you do all the cool stuff. The other thing that you're going to get is a breadboard and discrete parts. So all those gates that I was talking about, like inverters and AND gates, you're going to get circuits or parts that actually have those on them. In addition to that, you're going to get other things that will allow us to input 1s and 0s and look at the 1s and 0s. So things like switches and LEDs, and so you can zoom in, like these are switches right here, and there's buttons, and there's LEDs that you can see what's going on, and displays and buzzers and all sorts of cool stuff. You're also going to have what we call an FPGA board, and this is going to be a programmable logic device that when we design our hardware description language functional equivalents of circuits, we can actually synthesize it and download it directly onto this board, and then we can run the circuits. So, okay, so that's going to be kind of a high-level overview. The 4th thing you need is the ability to take a video. When you do the laboratory assignments, you're going to demo them by taking short videos. So all the labs can be demoed with a 2 to 5 second video. You build the circuit, and you take out your phone and you take a small video, and then you upload it to the course management system. So that's how all demos are going to be. Honestly, all these circuits, they're digital, right? They either work or they don't work. And so what you're going to find is that you might ask yourself, how in the world can you demo something that may or may not work, and how do you get partial credit? The reality is that you work on these circuits until they're done, and if you get stuck, you ask for help, and we help you, and you get all of these. So I have full expectations that your lab score will be 100%, because you just got to do it. The only way you can not get 100% is if you don't complete the circuit, and the problem is when you don't complete the entire circuit, nothing works. So they're kind of like all or nothing. Okay, so that's kind of what the 4 requirements are for this course. in terms of the materials that you need. So now let's take a look at the syllabus. And keep in mind that the syllabus that I'm going to look at is for one of the specific 4x4 sessions, so this just happens to be session 1. But the material, everything is identical on here except for the schedule. Okay, so a traditional syllabus, let's look through the kind of the boilerplate stuff. This is a course that's going to teach you about computer hardware. There are learning outcomes. So important, whenever you take a college class, you should always think about why you're taking it. You don't just take it to spend money, you take it to learn something. And so when you have a class, you say, well, what exactly am I going to learn? Well, what you're going to learn are going to be called learning outcomes. And there's specific learning outcomes for this course. Now, these are kind of high level learning outcomes. Sometimes we'll call them learning objectives. But they give you kind of the things that you should know after you complete this class. In terms of logistics, let's see. I'm your instructor. You can call me Brock. You don't have to call me Dr. Lemires. Brock is fine. I am located in Bozeman, Montana. I have a phone, but the preferred mode of communication is email. As you know, I'm teaching this class along with the teaching assistant Coulter Barney, who's also in Bozeman, and we are walking around with our phones constantly. So if we are live teachers, even though this is an online class, we are here all the time. I mean, this is a live taught class. So if you email me, we say that we'll try to respond within 24 hours, but in reality, I'm going to try to reply to you right away, even if it's just give me a second to try to understand your problem. So email is the preferred way to communicate with me. And I would honestly, or I'd recommend, always email both of us, because you never know. Between me and Coulter, one of us will be able to reply to you quite quickly. Okay. All right. We already talked about the required material. Prerequisite for this course is it's just a course in algebra. This could be a 100 level class, honestly, if you've already taken algebra in high school. But all you need to do is just have a math class in algebra. And then the website, the learning management system, is going to be called Brightspace. And this is how you access everything. This is where you get all the course material. This is where you do your multiple choice homework assignments and quizzes. And this is where you're going to upload your videos. And after we go through the syllabus and schedule, I'm going to show you the details of it. Office hours, really no notion of an office hour, to be honest with you. It's just, this is an online class. Just email if you have questions or you get stuck. Grading, 25% is going to be homework. There's 1,000 points available in the course. Okay. Labs are worth 45%. End of module quizzes are going to be 20%, and then you're going to have a comprehensive final exam at the end of the semester. And so you notice that the labs are worth the most. Okay, so almost half the class is labs. That's because that's where really all the learning comes from. It takes a lot of understanding and a lot of care and a lot of effort to get these labs working, and so they're weighted considerably more than homeworks or exams. Okay, grading scale, we're just going to go straight. 90 to 100 is an A, 80 to 90 is a B. Just a straight grading curve. Academic policies, this is where you say it. Don't cheat, but you can certainly work together. So what's the difference between working together on something and cheating? Working together is where you collaborate, and you can even have the same files that ultimately are turned in as long as you acknowledge that you're working with somebody. Cheating is where you just take somebody else's homework and turn it in, or you look at somebody else's homework. Okay. All right. Course components. How are you going to learn this stuff? Really, this course breaks down into this. You're going to read stuff out of the textbook. You're going to watch instructional videos that I've created. You're going to do homework, and the homework comes in two forms. One is a multiple choice quiz that'll be administered in the Brightspace system, and I'll show you that. The second type of homework is doing a simulation, and the simulation you'll run on this software that has to be run on a Windows called Model Sim. And you're going to take screenshots of your waveforms, and you're going to upload the waveforms and your source code to a folder, and then we'll grade it. Laboratories. There's going to be laboratories where you build circuits, and you demo these by, like I said, take a short video with your phone and upload it. The reason it's important to make them short is because with these high-def phones, if you take a 30-second video, I mean, it's like almost a gig. So I need these videos to be uploadable. So you really short videos. Okay. And then at the end of each module, there's going to be these quizzes. And so these cover everything that was covered in the module. And the difference between these multiple choice quizzes and the homework that are multiple choice quizzes is that the homeworks there is a deadline, but you can open them up and you can work on them over time. And you just got to make sure that if you save it and come back the next day and open it, at the end you got to submit it. End of module quizzes are timed. So this is to kind of simulate taking a timed exam in class where it's like, okay, you say start, the clock starts, and it's going to end at some point. So you have to be prepared. Okay. So you got end of module quizzes. And then we're just going to have a final exam, comprehensive, that'll cover everything in the class. And that is also going to be timed. And it's in the form of one of these multiple choice quizzes. Okay. Now here's the key. This is what you're going to have handy at all times, because this is going to be the schedule for the activities and the grading. Okay. All right. So this table, no matter what schedule you're on, is going to show you everything that we're going to do in the class and exactly when it's going to be due. So I have it broken down by week. Remember, I'm showing you the version for the 801 section, which is the first 4x4 or the first 4-week section. They're all different depending on schedule in terms of the time and the deadlines. However, the assignments are all identical. It's just a matter of when they're due. Okay, so let's take a look at how this looks. You start off with module 1. You'll notice that there's a homework on 1.1 and 1.2, and then there's a lab, and then there's a quiz, and that completes module 1. Notice that over here I list the deadlines. Deadlines are going to be Wednesdays and Mondays. Okay, so if you then go on, this is going to be, now we're on module 2, you're going to have a homework on 2.1, homework on 2.2, homework on 2.3, homework on 2.4, do a lab, do a quiz. And those are all due on Wednesday. So you start the class and you're going to have these deliverables that are due at noon on a Wednesday. Then you continue working and you'll have homeworks and labs and a quiz that are due the following Monday. So the deadlines are always set up to be at noon, and they're always set up to be Wednesdays and Mondays. And I try to keep that consistent. This gives you some flexibility because you don't necessarily have to do something and turn it in every single day. So it does allow you to have some flexibility, but it does provide deadlines. What I've found is if you don't have deadlines, or you just have a deadline like once every 2 weeks or once every month, everybody out, it's just human nature. You wait until the last minute, and a lot of times you'll get stuck in a situation where you've got 50 hours worth of stuff to do and you only have 8 hours to do it, and you just physically can't do it. So it's important to have deadlines, but since this is an online class, I try to make it as flexible as possible, and I try to keep them consistent. So what you should always do is you should always have this open and take a look at this and try to figure out what is coming up, what's the deadlines, and what do I need to do for the next deadline. Okay, so then you just scroll through that, and there you go. On some of the shorter classes, I actually provide you a grid, and so you can kind of see the flow of how this works. Not on the 12-week one, because you have more flexibility on the 12-week session. But for example, let's just look at a 4x4 version of this class. I actually say, okay, you should be working 4 days a week. And so on Monday, work on these things, they're due on Wednesday. On Tuesday, work on these things, they're due on Wednesday. Then you go over here on Thursday, you work on these, they're due on Monday. You work on these, they're due on Monday. You're done with that? Repeat. These 2 days, their activities are due on Wednesday. These 2 activities are due on Monday, and you just continue on. So that's how you keep on track. Now, it's important because when we look at the learning management system, you're going to see all these activities, but it's up to you to kind of keep track of when they're due. And I'll send emails and everything, but you know, this is an online class, so you're going to have the burden of keeping on schedule. Finally, in the syllabus, you're going to see the learning outcomes, and this is specific. So every single section within the textbook has a specific thing that you should be able to do when it's done. And so I break them down, and I also give you kind of this notion of like what level they are in this thing called Bloom's taxonomy, which shows you, is it lower level learning, like just creating knowledge where you know like terminology, or do you use that knowledge and you comprehend how it works together, how something works, or are you applying it? Are you analyzing? Are you synthesizing? So as you go higher in the Bloom's taxonomy, the level of learning is more complex, because if you think about it, like to design a circuit, you needed not only the knowledge of how the circuits worked and what they were called, you needed to be able to apply a design flow and analyze whether it was working. And so not all learning outcomes are equal. However, you can browse through these and you should be able to do these after you are done. Okay. All right. So that is the syllabus, and that's the logistics. So the next thing we want to look at is the learning management system and look at how you actually get started. Okay. So now let's finally look at the Brightspace learning management system, or learning environment, or just website. This is where you log in and get going. So to start with, if you're seeing this video, you probably already logged in, but ecat.montana.edu. You log in with your MSU NetID and password. If you ever have any trouble logging in, they've got the forget password, but you can also, there's links on here to call the people. Once you log in, you're going to come to your home screen and you'll have a course that shows up, and it'll be the one that you're enrolled in. When you click on it, you're going to come to the Introduction to Logic Circuits main page, and the main page just basically looks like it's got all the tools that you can access up at the top in this ribbon, and it's going to have an announcement. Now the announcement page, I don't use announcements. All I do is I put one announcement that says welcome. If I make an announcement to you, I'm going to do it through email. Okay, so you'll never see any announcements right here other than just welcome, to know that you actually came to the right spot. What I do is I do give you a link to go to the first content page, but you can also find it through content. Okay, so the way that I break everything up is I lay out the course using what I call content pages. Okay, so when you come in here, you're going to see a web page in the content area that is for every module. I also give you a course information and syllabus page at the beginning and a final exam page at the end. And so when you click on these, it's going to have everything in here linked for you. Now, when I say everything, it's like files, quizzes, and stuff like that. You're going to see links in here. Everything can also be accessed up here on this ribbon. You can access the tools from many different places in Brightspace, but I try to link everything so that you can get in the habit of just kind of living on these pages. So when you come into the first page, what you're going to see is, this is the course overview. You're going to see a link to the syllabus. That syllabus is very handy because it's going to have the schedule on it. That's what you're going to want to watch every single day. Course overview video, which you're watching now. And then you're going to see my contact, Coulter's contact, the required materials, and that's basically it on there. Okay, so that's where you're going to get the syllabus. Now what happens is, I'm ready to start Module 1 and start the class. You're going to click on this arrow, and you come to Module 1. So here we are, and what you're going to notice right away is that you're going to see the learning outcomes and then the learning activities. Notice that this is going to consist of read, watch a video, do a homework, repeat, a lot of that. Okay, so for section 1, you're going to read the textbook, watch the video, and then do a multiple choice quiz on here that'll actually be worth points. And when you submit this quiz, it'll give you your points right away. Then you go on to section 1.2, you do the same thing, and then you're ready for a lab. So then in this lab, what you're going to do is you read the description of the lab. I do have an overview video for every lab, and the overview videos, they're kind of meant to be watched as you do the lab. So I'm actually sitting there working through the lab with you in a lot of cases, and so you can kind of play it, understand what's going on, then do your own, while the videos pause, etc. And then when you're ready to do your deliverables, you upload them to the assignment folder. And then in this module, it's a relatively short one, so then you go ahead and take the quiz. Let's take a look at what a video looks like. So if I click on this video, lo and behold, it's a YouTube video, right? And it's me. So there's my hands, and I write out a bunch of stuff. And you just sit there and listen to it. You know, honestly, most people watch these at 1.5 speed. So if you want to just crank it, you can change the playback speed to go through these quicker, as long as you can understand me. I usually watch videos as fast as I can, and then when they get to something that is more complex, I'll slow them down. So that's what a video looks like. You can subscribe to my channel if you want to make sure to get other updates on other content that I add. Now let's say that you watched a video. Let's look at what a multiple choice quiz looks like. Mine's going to look a tiny bit different than yours because I'm the instructor. But when you click on it, you're going to come in and it's going to, let me show you what the quiz would actually look like. So okay, so here's what a quiz looks like. Pretty standard. Question 1, what part of any system will always require an analog component? You check whatever you want here. You know, I don't know, blah, 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 blah. I don't want to give you the right answer. Take that thrill from you. So you go through these, and when you're done, you can submit the quiz. However, very important, make sure that you understand that you can also save the quiz too. You can save on a homework and then come back later and then keep working on it. This one appears that every time you do it, it saves it, so you can get out of here and come back in. But submitting is where you say, I'm done and I want my grade. Okay, so we only submit when you're ready. Notice that quizzes have multiple questions per page. This particular one has 10 questions on one page. Other quizzes are going to have multiple pages, so you kind of always want to look over here to the left and get a gauge where you say, oh, this has multiple pages, because you don't want to accidentally forget to go to the next page and miss problems. Okay, so that's what a quiz looks like, and they all look like that. Let's see. It pops me back. I come down here, video, quiz, video, another quiz. Let's take a look at now you're ready to do your first lab. Let's click on this lab handout. This lab handout is a giant PDF that has all the assignments in it, and you only have to download it once. Okay, it has every lab exercise for both classes, 261 and 367, and it comes in here, and let's go down to lab 1.1 and see what it looks like. It has information on all your lab kits. Okay, so here's your first lab. You are going to blink an LED with the arbitrary waveform generator. So it's going to tell you what you're trying to do, the parts needed, what the deliverables are. This is a key thing to always read right before you start, because this is how you get graded. So when you do this lab, you're going to demonstrate the use of an arbitrary waveform generator on the analog discovery to make an LED blink at 2 Hertz. So you are going to upload something and that's worth 50% of the exercise. Then you're going to take a measurement, and that's worth 50%. And I'll show you where I highlight in red how you actually do these demos. Okay, so anyway, here we go. You're going to build a circuit. I give you the circuit, and here's what it's going to look like. You have a breadboard that you're going to set up. This breadboard allows you to wire stuff together. So you go ahead and set some wires to get all the power and grounds ready. In this lab, you kind of look at how to read a resistor. You look at how an LED looks. You look at how to actually insert it in the breadboard and wire up the circuit. Then it talks about the analog discovery and how you actually connect it. And so this is kind of what it'll end up looking like for the first demo. Is you're going to have this analog discovery. You're going to install some software to actually control it. You're going to take a measurement of what's going on. You're going to drive a signal into it to make the LED blink. And then I show you how to set up, everything that works, what you should see. And now you're done with the first part. In red, I say, take a short video showing the operation of your circuit with the blinking LED. This video satisfies the requirements for deliverable 1. So as you walk through this, you'll get through the end of a part of the lab, and then in red, I tell you, what specifically are you going to upload to get graded on, okay? This one has 2 parts, so I tell you to go through the oscilloscope, and in this situation, you're taking a measurement with the analog discovery. The second part of this lab is an image. So you're actually going to do a screenshot of the measurement you take, and that's what you upload. So it's very clear, or I try to make it clear, what you're going to specifically do for each lab. Okay? But I mean, you're going to basically break out this lab kit, and you're going to plug in everything to your computer, build circuits, and run them, and off you go. Now in this module, like I say, there's an overview video for the lab, and then I give you a link to where you upload your deliverables. Then this one you're done, and you do an end of module quiz. Okay, so then you're done with that, and then you're just like, okay, I'm ready to go to the next one. So you click on this arrow, module 2, and look at it. It's almost exactly the same. Read, watch video, homework. Read, watch video, watch video, watch video, homework. Read, watch video, homework. Read, watch video, watch video, watch video, homework. Then do a lab, then do a quiz. Okay, so it repeats. It repeats, it repeats, and you just crank through these things over and over, and they get more complicated, they get more interesting. Some of them take longer, but I try to reflect that in the schedule. And then you just continue along until you are done with the course and you follow along with your deadlines. And that is everything that you need to get started. Okay, so here's what you're at now. At the end, you'll have a final exam, and all I do is I just give you a link to it. But that is the course. So at this point, you're ready to start. So you can, this video will end, and you can go to Module 1 and start doing all the things that you need to do. The guidance, one thing that I'll leave you with is this. This is a live taught course, meaning that I'm here throughout the entire course. Coulter's here throughout the entire course. Preferred mode of communication is email. So if you get stuck on something, email us. Don't stay stuck for long. If you're sitting there for hours and you just can't get the lab to work, don't stay stuck for 5 hours. Email us and let us know what's happening. You'd be shocked at how easy it is to help you via email with the ability of you showing us pictures of what's going on. If you need to do it like a video conferencing like Skype or Google Hangouts, we can do that. But we've been teaching this course for a lot of years now, and you'll be shocked at how easy it is if you rely on email. I'll say one last thing on the email. Your Brightspace email, I set mine to forward to my preferred email. So if you email me in Brightspace, it'll go to my preferred email, but I don't send emails to the Brightspace. I send emails to your preferred email that you've set up at Montana State in my info. So make sure that you have that, that you're checking the right email. With that, I will say good luck, and I look forward to working with you this summer.